As you may have imagined from the title of this unit, we are going to deal heavily with data. And I think you also appreciate that data is essential for making informed decisions. Imagine trying to buy a car or a house when you don't know anything about the price of cars. You need the data about this price in order to make the purchase. But data is not always a price. It is sometimes obtained from surveys. You ask people about something, and the answer to their question is a piece of data. Now, the answers differ, and the type of answer determines the type of data. Let's see what that means. If in a survey we ask how many refugees are there in the world, or how much money do you have with you right now, or which birthday did you last celebrate, or how many operations has this doctor performed last month, you can see that what's common between all those questions is that the answer is a number. For example, let's say this doctor operated on 13 patients last month, and that your last birthday was the 15th. And how much money do you have with you right now is something like 12.45 JDs. Well, as far as refugees in the world, there is a number, but it might not be easily calculated. But you'd probably say it's approximately, let's say, 46 million or something of the sort. Now, as you can see, what's common between all those questions is that the answer is numerical. You answered by giving a number, and not just any type of number. If you look at the number of operations this doctor has performed, the number is going to have to be an integer. He can't have operated on 12.5 patients. So this kind of number is a kind that jumps from one value to the other. It's either 13 or 14 or 15. Your last birthday was either the 15th or the 16th. It could not have been the 15.1. The same applies for money. If you have 12.45, you may have 12.46, but you can't have anything in between. So again, there is a jump from one value to the next, but the jump is in 0.01 of a JD. Here, the jump is in 1 year or in one operation or whatever. So this kind of variable is called a quantitative variable. Because the answer is a number, and it is called discrete in the sense that the value jumps from one value to the next. If we look at another set of questions, how tall are you? You may say, I'm 160 centimeters tall. But can you be sure that you are exactly 160 centimeters tall? Actually, you can't. Because you may be 160.325179, etc. And the exact answer depends on the accuracy of the measuring instruments that you have. And you probably don't have an instrument accurate enough to give you an exact value. Actually, this kind of value cannot be measured exactly because this decimal goes on forever. The same applies to how long did it take you to finish the race. You can't be exactly sure of the time because your measuring instrument gives you, let's say, the time nearest to the nearest 100th of a second. The same applies to temperatures or the mass of apples. The answers to those questions are also numerical, so this variable is also quantitative. But it's not discrete, it is continuous. in the sense that for you to grow from 160 centimeters tall to 161, you will have grown through all the possible values from 160 to 161. You do not just jump from one value to the next. However, if the question is how tall are you to the nearest centimeter, or how long did it take you to finish the race to the nearest 1/10 of a second, i.e., when you are asked to round that value, in that case, this variable, even though it is continuous, it behaves like a discrete variable. And the reason is, when you round your height, you give your answer as either 160 centimeters or 161 or 162, so the values jump. So in this case, even though the variable is continuous, it just behaves like a discrete variable. Now consider this set of questions. When you're asked about fruits, or countries that you visited, or the type of calculator or car, your answer is not a number. It's a word. And even when you are asked about your car plate number, you will give a number, but that does not represent a measurable quantity. It is just a symbol. It is just a label. What's your blood type? You give a letter, sometimes with a positive or a negative, a positive or negative, and so on. In this case, because the variable is, the answer is not a number, we call this a qualitative variable. And this includes the car plate number, which does not represent a quantity. And because all of those represent names or symbols of things, this qualitative variable is called as nominal. There is no ranking. And if your blood type is A, it doesn't mean that it is better than blood type B. Again, if we look at your scores, if I ask about your scores, in this case, you answer by giving a letter. It's either an A or a B or a C. But in this case, A is better than B. B is better than C. When I ask you about your achievement level in criterion B task, you give me something between 1 and 8. But that 1 to 8 is not a number. It is an achievement level. It describes a set of descriptors that you have achieved. So 8 is better than 7, but it does not represent a certain quantity. Sometimes people ask on a scale of 1 to 5, how hungry are you? It does not represent a numbered scale. It's not something that you count or measure. It is just something that you assign a degree of hunger. Sometimes in questionnaires, you are asked a question and you're supposed to circle an answer. Strongly agree, agree, disagree, strongly disagree. So all of those are, again, qualitative variables, your answers, but because they all represent a certain order, we call them ordinal. So in summary, if we look at the types of data, we have quantitative data that can be either discrete or continuous, and we have qualitative data that can be nominal or ordinal. And yet, one of the toughest questions to contend with is how do you process and present the data? Now, this is a serious issue in statistics. That depends on the type of data. because dealing with numerical data is not the same as dealing with qualitative data. It depends on the size of data. If you have 5 data points, you can process them easily. If you have 3 million points, well, the processing is going to have to be different. It depends on your purpose. Why are you presenting this data? What do you aim to highlight? What decision are you aiming at? And finally, your audience. Who is your audience? And the level of complexity may be influenced by your audience. There are certainly other things to consider, but let's just stop at that. And to highlight my point, let's say that at the end of an important countrywide exam, School A announced, we have achieved a 100% pass rate. Now that could be a brilliant result because all the students passed. But this implies that the school has processed the data, calculated the pass rate, and gave you a number. It was their choice. The audience is obviously the parents or prospective parents. But what did they hide? And what did they highlight? Let's compare this to another school that announced that 5 of our students scored more than 95% in the external exam. Now, this is commendable. And if you don't think what's behind the data, you may be tempted to send your child to school B. And compare that to a third school that says that the graduating class average was 85%, which is a very good average considering the wide range of abilities in any class. So each school had its own data. They processed the data and they presented something to their audience. One can say quickly that School A achieved a commendable result, but by presenting the pass rate, they are hiding the actual scores that the students got. They may have got a very poor average and that the student all passed barely. So even though the 100% seems impressive, you have to consider what is behind it. Consider School B. They are focusing on the best achievers. Now, what about the rest of the class? Where did they score? Did they pass? We don't know that. And look at School C. The graduating class average was 85%. The good thing about this school is that they calculated the average of everybody. But does this mean that some people failed? Does this mean that they were all clustered around the 85 and nobody scored high grades? We don't know. So you should always ask yourself, not only what am I being told, what am I being not told? And as we have seen in the previous example, processing data usually leads to a loss of detail, but better clarity. We always say clarity is gained at the expense of detail. Consider the example of those schools. We have lost some detail. We don't know the individual grades of the students here, but we have one number that represents the school in its entirety. The same applies to this school. So the loss of detail allows us not to be lost in loads and loads of numbers, and we have one clear overview of the data. The question is, how ethical is the processing? How fair is it? Are they ignoring something? Is it correct? Are they hiding something on purpose? Whenever somebody uses a statistic or a number, we should always think, how did they obtain this number? Is it logical? Is it not? Are they choosing certain numbers that suit their purpose? Or are they presenting an objective picture? Is there something missing? We should always go behind the data and think about the overview of the whole situation.